Hi everyone, welcome to this session. I'm going to cover two widely used platforms for big data processing using PySpark. There are many applications and platforms used for big data processing. I'm going to cover two important ones, and the first one is Google Colab. This is a free cloud-based platform for Python and also PySpark coding. So how to do so? You need to simply type colab.research.google.com, and then you need to only log in with your Google account. Then go to File, New Notebook, and we can open a notebook for Python coding. So you can start by changing the name of the file, for instance, test1, and then we can start. So to be able to start coding big data applications using PySpark, we need to firstly install PySpark using pip3 for Python version 3. As you can see, that it's going to download the latest version of PySpark, which is 3.2, and the actual size of this file is 281 megabyte. So it would take a couple of seconds, and it's going to be done in a short time. So since we are using this free cloud-based platform is running over one single machine, from Google servers, and the most important things here is the number of cores. As we discussed within previous session, I've explained for parallel processing using Spark, CPU is really important, the number of cores, because the number of partitions is going to be done based on the number of cores. So after PySpark installation, we have to load the the required libraries. So I would say from PySpark, import Spark. So a Spark context. If you remember from previous session, I've said a Spark context is a driver program, is going to be like a border between end user and a Spark cluster to get information from end user and also send back the result to end user, and then a Spark configuration to configure the Spark. So press Shift Enter, and then here I have to do the configuration. So I want to say initializing Spark. So how to do so? Conf is Spark configuration, and then we have to set application name. So I want to give a random name like test app1. And then the important parameter here is set master. So set master is going to allocate a number of cores. So I would say local means the local machine we are running this cluster. And then between this bracket, you have to mention how many cores you want to take into consideration for a Spark computation. So if you would say 2 means incorporate 2 cores. If you say 4 is going to take 4 cores, and so on. But since we wish to take the maximum number of cores, we would press asterisk, means use as many as core available. So, and then I would say SC is Spark context, and then there is conf parameter, and put this configuration we have done. So it's going to set up the cluster with this name and this number of cores, and then we have to check how many cores are available within this free platform. So, and then to make sure everything is going well, you can print SC. So it's going to say we have a Spark context with this number of cores and this application name. So to make sure how many cores we have, so you would say sc.default parallelism. So if you press Shift Enter or click on this Run button, you would say 2. It means there are only 2 free cores available. I mean, for this editor that we are taking for PySpark. So then from next session, we will start coding for big data processing. So now we could set up successfully Spark and all the components over this cloud platform. Let's take you into the desktop version. So for